The amount of smoke coming out of it, like a barbecue, that is not something that you would see. When it hits the ground, it's actually really cold. I am Professor Gretchen Benedix. I have been studying meteorites and asteroids for about 20 years. Today we're going to be looking at asteroid disasters in movies and on TV and judge how real they are. Now we can get asteroids that are fully metallic with all the canyons and things. The asteroids that we do see do not have this kind of debris cloud around them. An asteroid will generally not have too much of this gas coming off of it. It may have some ice in it, that's not going to be the majority of it. I'm pretty sure that we would see something that size headed for us well before it got to that point. Very unrealistic. The biggest myth is that you actually have to steer your spaceship to avoid asteroids. There's a ton of bodies out there. It's a huge amount of space. It's really hard to kind of get into a situation where you might hit something accidentally. You could potentially land on it. It's not like landing on Earth. You're dealing with a totally different gravity regime. You know, we've had a couple of really tiny asteroids that we've got missions from Japan and the US, and they have these little touchdown things. And it's really hard just to do this tiny little drone-sized thing and land it down on the surface of the asteroid and then get it back off. The amount of power you'd need to actually explode it is impossible. We don't have enough explosive material on the Earth. So there have been some studies done that have shown that if you take an asteroid 20 kilometers across, you need something like 200 gigatons of explosion to break that apart completely. Now, the biggest thing that we've ever exploded on Earth was 50 megatons. So you'd need 4,000 of those to blow up something 20 kilometers across. This thing in this movie is 1,000 kilometers across. You'd need 130,000 50 megaton bombs to try and blow that particular asteroid up. A shock wave, it's a pressure sound wave. You need atmosphere to have sound. So when the sound is playing in the movie about this explosion happening, that's possible because there is a lot of what we can see as atmosphere there. So there's some gas molecules, and that's going to cause that sound wave to travel. But it's space, so usually there's a whole lot of space in between all of these molecules. So the sound is not going to be what we hear here on Earth. You will have a shock wave, but it won't travel out both sides of a thing. It'll only travel out one direction. That's not how you would actually try to destroy an asteroid that's coming for you. So I would give it a 1 out of 10. 65 million years ago is not when the asteroid got knocked out of the asteroid belt. That is when the asteroid actually hit the Earth. Number 2, wrong. The asteroid belt does not look like that. It's not a donut of rocks that are that close together. Sometimes you can get an asteroid family, so you can get one asteroid that has like maybe 3 or 4 other asteroids kind of close to it. So this asteroid gets knocked out. You can have collisions every once in a while. They do get the size of the rock correct. Over time, the sizes of the rocks that are out in space have actually gotten smaller because they do run into each other, but they're really far away from Earth. So not all of them are going to get onto a collision course with Earth. And they don't necessarily impart enough energy to stick it on a direct collision course to the inner solar system. The collisions that occur out there over time have gotten fewer and fewer because we've kind of gone from a really chaotic system 4.5 billion years ago to now it's pretty quiescent. There's a mission called DART. They're trying to take a small asteroid, they're going to push it with their little spacecraft and see if it will change its orbit in any way. Then the movie takes a different tact and says, well, it missed. The orbit was such that it kind of got close, but it flew by. Now, we do have objects that fly by. That's kind of cool. And that I don't think a 6-mile asteroid would actually skim the atmosphere and then bounce out again. But you can do that with smaller sized objects. Again, 1 out of 10 for realism. I love this show, and in terms of the realism about everything else, they actually use real asteroid shape files. They have coated it with material that would make it hard to see. The amount of light that's reflecting off the surface is the only way we can tell that that thing is there. So we can see it moving, and if it's moving fast and it's bright enough, the amount of light it reflects from the sun is how we tell it's there. So if they've coated it with this coating that's stealthy, then system that they have in place to detect incoming asteroids, that would fail. So that actually makes sense. I would be surprised if he didn't hear it, to be honest, because that would be a very loud, rumbly noise that you would kind of notice before you saw the light. There have been fireballs that have come across, we get images of them and people don't hear them or see them. Or sometimes people will hear something but never see the fireball itself. For this particular scene, all of that makes sense. You'd feel the thermal radiation before you felt the shock wave. That's definitely realistic. So even if you're like 500 kilometers away, you might feel the thermal radiation in maybe a minute, whereas you might not feel the shock wave for half an hour or more, an hour. And the effects of the thermal radiation would be burning. Your clothing could burn off. Your skin might not, but I imagine that it would. It would just depend on how far away from the impact you are. It's at least an 8 out of 10 for realism. Pause on the comet. Let's talk about that first. There's this whole bunch of smaller bodies in between Mars and Jupiter that we called asteroids, and asteroids are really rocky metallic bodies. Comets come from farther out in the solar system. Comets are composed primarily of ice and dust. The fireball that we're seeing here, these bits of material are fragmenting off, and they are still moving fast enough so that they can exhibit a glow as well. That is a normal thing that you would see, just not at this size and distance. The size of this rock is about the same size as the rock that caused the extinction of the dinosaurs. So having shelters is a good idea because we know what that asteroid did. We'd want to be underground. Potentially could devolve into that level of governments making choices about randomly picking people to save and then finding shelters for them to go into. What we're seeing is that the entire Earth has been wrecked and poisoned. There would be potentially a global dust layer on top of everything, but you would not necessarily see the level of shock damage or structural damage that is being shown here for every place on the planet. You could potentially have sunlight be blocked for quite a while, and then that could settle down. 2 or 3 out of 10. We've never witnessed something this size hit a terrestrial planet.
Come to a simple.
What we're seeing is the smoke trail. We're not actually seeing the fireball and then an explosion. That's not how it works. It would be something that is like a fireball and then a trail of smoke behind it. You know, we have evidence of this. In 2015, this several tens of meters wide object came through the atmosphere in Russia and it fragmented and people caught the whole thing on dash cams. So the impact itself would potentially cause a lot of material to come out. I don't think it would go straight up like that. It would more spill out sideways, and then the shock wave would come after. Certain impacts can burst your eardrums because of the air burst afterwards. So if it's big enough, yeah, you can get noise levels that are well beyond, you know, breaking your eardrums.
And that's the way the cookie...
There's a trail, a skidded track to the end of the trail. No, that doesn't happen with impacts. Impacts are an all or nothing thing. Even if they come in at a really steep angle, it will still make a single hole and it won't have a gouge in the earth leading up to it. It's gonna be 0 on this one.
Does that look like a problem to you?
Meteor shower!
They call this a meteor shower. The size of that thing is not a meteor. Those are big rocks. We now know meteors are really tiny, small specks of dust. So meteors are different than asteroids and comets and meteorites. We're talking about tiny dust particles that are between the size of sand grains to maybe a small pebble size that are burning up in the atmosphere. So this is a fireball, or even we could even call it a bolide if we're feeling super scientific. If you see a fireball and it looks like it's headed for you, stand there until the very last possible second, because if it's small, you might be able to jump out of the way, but probably not. And if it's big, it doesn't matter. I get this a lot. I saw a fireball over there, so it must have just landed over on the other side of my field. No, if you see a fireball, it's actually really far away because it's very high in the atmosphere.
Woohoo! I'm on fire! Woohoo!
You would not be catching fireballs. And if a fireball hit you like it hit those two, you would be fried. You'd be in the crater that was left behind. From the perspective of science, it's not realistic. So I give this, I think, a 1 out of 10. From the perspective of a rock hitting the ground that came from space, yes, that's a meteorite.
Honey, bring your phone. Come on, come on.
No, don't go near, don't go near.
It glowing on the ground, no, that's wrong. So that means there's something inside of it. It might glow as it's coming through the atmosphere because the chemistry of the rock might interact with the atmosphere, so you could get different colors that way. Purple would tell you something about the elements that are in it. Meteors that glow different colors, but again, those are just small pieces of dust.
Smells.
The amount of smoke coming out of it, like a barbecue, that is not something that you would see. A meteorite coming through the atmosphere, it heats up, but only the outside. So when it hits the ground, it's actually really cold because space is cold and it's been out in space. And there have been reports of people finding meteorites very shortly after they've fallen and them having ice on them. And if you're going to get burned from it, it's going to be freezer burn, not a heat burn. You can get close to them as long as they haven't come in at a massive speed. Peak scale meteorite in the US, October 1992, when the meteor was seen across about 16 states, it actually hit the boot of a car in New York and punched a hole through the car.
Did you plant those?
No.
It would not be something that is actually alive after having gone through that atmospheric thing, unless the meteorite is somehow a spaceship, which generally they're just rocks. The idea that there could be life on a meteorite, that's one area of study in our world. We check for evidence of either organic material or like the precursors of organic things that could potentially harbor life. We haven't found any so far. So we've found precursor materials, but no actual evidence of life. The color, it doesn't glow on the ground at all. I'm going with 0 out of 10 on this one. This is the comet, and it is hitting water. The odds of anything hitting water are really high on the Earth. That tsunami wave looks very high to me, but I think you could get a tsunami wave that was something like 600 meters high with the size of that object. The running away part, in general, you're going to have some time before the tsunami hits. As we know from recent events with volcanoes in the middle of the Pacific, it takes a long time for the tsunami to get to wherever it's going. If the impact is upon you, you have no warning. The only way that happens is if we haven't tracked it. And the only way that happens is if we're not looking. And so none of those things are happening. You wouldn't have this level of water coming inland as far as I think this is. So even if the impact had happened very close to shore, the depth of the water would be less, so the wave would be lower. This is completely no. I would probably head for the middle of a continent if I knew it was going to hit water. Deep impact for realism, I give it a 1 out of 10.
Why does the ephemeris keep getting lower and lower? Professor Mindy?
So this is really good. I like this aspect of it. Is we're going to run through the numbers and we're going to do the calculations from first principles. 0.0 means we're getting close to the Earth. That doesn't mean it's going to hit, because 0.05 AU is still farther away than the moon. The way we currently check for things that might be potentially hazardous is when we do these calculations, we work out, well, if it's going to be closer than 0.05 AU from the Earth, then we call it potentially hazardous. There's a good chance it'll never hit. So his worry is probably not unfounded. It happens several times a year that you'll get something at this 0.05 or less. But generally the sizes of the objects are only a few meters or tens of meters across. This particular size comet would not completely decimate. It would not take out the Earth. It would destroy it, but it wouldn't break it apart. It would make it a mess, but it wouldn't even wobble it off its orbit. I think they said it's like 10 to 15 miles across. Even the moon forming event, which was a Mars-sized object smacking into the Earth, did not destroy the Earth. The probability of something the size of what these things show actually hitting is so infinitesimally small at this point, because the solar system has evolved over time. So don't be afraid. We're doing a really good job of tracking things. We have a much better handle on how we look out in space. Thanks so much for watching. If you enjoyed this video, click on the one above.